words for which people use the wrong spelling more often than the correct. And here, as you can see, things like edit distance are not going to work because somebody writes TOM. That's very, very far away from tomorrow in terms of edit distance. So, what has been done? People look at how you learn mappings. So customer, people write different ways in which they have written customer. And what do you use to do the correction? You can't use edit distance anymore. So what do you use? So you use the context, hoping that the context is remaining the same, and you are going to apply this iteratively so that the context words become cleaner and cleaner and cleaner, so that you get to that correct form. So as you can see, scheme, SCEAM, SCHEME, the left and right context, it's somewhat similar, and that's what you're trying to exploit here. Often, the content words like ISI, if you're trying to write, ISI, you're not going to make a mistake in ISI. Or if you're saying that I want to buy a phone, the content words are typically not corrupted. It's the other words around it which are corrupted. So some of these, features are typically used to sort of make this correction and to ensure that, you still, in spite of this heavy tail distribution of words that you have, you still try to make the corrections as far as possible. Now that was at the word level. Now you can do the same thing at a sentence level. If someone is trying to, if you have a correct words like how do I activate homing, what are the grades for homing within India, and somebody is typing a question on SMS saying that, give me the answer to this. This person does not know what is there in that fact database. Right? So either that answer to that question is there or it's not there. If it is there, you need to match it to the correct, right? And here, just like for a single word error, a word in error, the customer or the tomorrow case, you're looking at, the complete sentence and you're trying to match it with the sentences there. But here, remember, there is no correct way of writing that sentence anymore. People can write the same sentence in multiple different ways because of the creativity of the language, because the language allows us to do it. We can say the same thing in multiple ways. We probably cannot spell the same word in multiple ways because there is a dictionary, but we can put together words in multiple ways to form sentences. There is no dictionary for that. So that's where the complexity comes in when you're dealing with sentences. So here again, you have to deal with something like, just like in the word case, you had edit distance, and then you brought in the context. Here again, you have to do that. And you have to basically search through a space, right? Which is that you have, these words, good place to buy whatever, something. And there are multiple ways in which that same word can be expanded. And then you're running through the search space, which is at least finite in this case because the fact database is limited. But if you are doing it across all of English, then you are in trouble. Because what do you search against? The other is, so call centers. India has, at least at some point, it had the maximum number of call centers anywhere in the world. Now I think it's Philippines or wherever else. Right? So if you look at these calls, they are very repetitive, right? The call center employee, or it depends who is calling you. If you have a problem, you call the call center employee. He'll say, "Hi, how are you, sir? How can I help you?" Then you say, "I have this problem with my computer, it's not booting." Then he'll say, "Okay, sir, you do this, you do this." There is a set pattern there. There is a template that person follows. As far as possible, that person tries to bring you back to that template he is following, because that's what he's been trained to do, and that's what he wants you to follow, because he wants to finish that call as quickly as possible, solve your problem, get rid of you, go to the next one. Because that's how he's measured, based on how many calls he can answer competently in a given day. Right? So a call center employee who handles 500 calls versus another who handles 300 is doing better, and he is rewarded appropriately. So his goal is to follow that template, try to get to that flow, almost like a chess move. Check this, quickly he's going to make his next move. So there is a pattern that person follows. So if you look very closely, you'll see that all call centers have these patterns. Their employees are trained on these patterns. So if you look at it, it should be an easy problem to automate, right? Because there is a template there. There is a state space diagram. Every time you're in state, every time somebody says hello, how many things can you say? You will say hello, or you might say, "How are you?" Or those are the limited number of things that they can say. If you ask for the credit card number, that person is going to give you the credit card number, or maybe he will say something else. So at least the states are limited, and from each state there are a finite number of other states to which you can go. So if you look at these conversations and try to learn, if you try to make a computer program learn how to converse like the call center agent, what would you do? You would give this computer program all the bunch of conversations between call center agents and people. That's what you would do, right? And then this computer program, what are the steps it will follow? First thing it will do is, it will try to form this state space diagram. It will say that the first question I should ask is, "How are you?" The next question I should ask is, let's say it's a taxi booking. "Sir, or ma'am, where do you want to go? Where are you currently? At what time do you want to go?" These are the specific set questions, and the system should automatically learn these things. If it is given this corpus of conversations that have already taken place, it should learn from there, right? Now, where are the challenges in learning from there? One is, these are conversations over voice. So any automatic speech recognition system makes mistakes, and because it makes mistakes, these corpus of conversations that this machine is learning from is no longer an accurate corpus. It has whatever, 30% error, 40% error, some n% error. Secondly, because people can say the same thing in multiple different ways, this system now has to at least try and learn some of these multiple different ways in which things are said. So what it needs to do is, it needs to transcribe the calls, it needs to do some sort of normalization of these calls, it needs to mine what patterns are there in this call, and based on that pattern, it now needs to say that this is my state space diagram. If I am in this state, if the person says hello, I should say hello. If the person says, I want to go to Howrah station, you should say, okay, what kind of car would you like? How much luggage do you have? Depending on what the question is, there are only a set number of things that this next step should be, and that's what this program should learn. And that's what this corpus is really trying to make this system do. So things like, have you rented a car from us before? Have you rented a car before? People can say the same thing in different ways, and the system should be able to say that, okay, these are not different things, they're all the same. They're all saying that want to rent a car. That's what it's trying to do. How does pattern mining work typically? So pattern mining works on frequent patterns, right? It's going to look for, given a corpus, what are the frequent n-gram sets? What are the frequent patterns in the dialogue? That's what a system tries to learn. But when there is noise, that system is trying to, when it's trying to learn, its task is much harder because of the errors, because of the language that is being used here. So you have to, you have to devise new ways in which you are going to do this pattern mining, maybe with skips, maybe allowing for some noise in there. And that's where, the challenge comes in, right? Because there are a preset set of algorithms that were doing okay on Wall Street Journal and very well-formed text. But now you've got all this noisy text, and again we're struggling. We don't have these algorithms which can work on this new forms of data that we're seeing. So things like, I would like to pick the car at SFO airport, I would like to pick it up at city center. All of these you want to normalize it and say that, okay, that's a place, that's a location in the city. So that at least, your dialogue is not, put off by the fact that I say, I want to go to Kolkata, I want to go to Delhi. Now the variable here is the location, and the system should understand that the variable is the location, which could be Kolkata or Delhi. But the rest of the sentence is the same. So when it builds this state space diagram, it is supposed to say, I want to go location. That's what it's supposed to learn. It's not supposed to learn, fit itself to individual pieces of data like Delhi, Kolkata, Chennai, and everything else. So these are all, challenges which today machine learning, all of, the community is sort of only now beginning to look at some of these things, because these are data, one, because the data set is not available, two, because the noise forms are not well defined, three, because you don't know how well your system is doing, because nobody knows how to measure this noise. So you also need to learn that, before confirming the booking, I first need to make a booking. Before I'm not supposed to keep saying hello, how are you at every point in the conversation. That only happens in the beginning. I'm not supposed to say bye till the end of the conversation. So these are all things that the system now needs to learn based on this very noisy data that it is seeing. Noisy because of the speech recognition errors, noisy because of the complexity in which people can say the same sentences, the multiple ways in which they can say. I'm not well here. So we are getting now to a point where we're looking at these multiple data sets, and what we are seeing is, if you want to create any single view of anything, then you need to gather information from multiple different sources. And now slowly we'll come to that question this person asked around, why do you want accuracy? Why do you care about accuracy? So one of the things that companies today are trying to do are things like understand more about their customers, understand more about people who are out there. So, for example, banks want to know, typically how banks operated today was that they knew that, okay, you are a person who opened an account with them in 2005. Typically, you maintain a balance of 10,000 rupees. Every month you withdraw 2,000, 3,000 and deposit 4,000, 5,000 or whatever, and that's your set pattern. And they also know that you are, let's say, 25 years old. So based on all of these things, they say, okay, this person is 25, this person is likely to enter the job market. This person is likely to get married. So based on that, they then say that, okay, I'm going to give this person a personal loan. I'm going to give this person a home loan, because 25 to 30, person gets married, gets a job, first thing he tries to do, buy a car, buy a home, those are the things they want to do. So that's how typically today companies target their customers. Success rate with these, less than 2%. Every ad that the company sends you, let's say a bank, let's say some person tries to call you, sell you, sir, I want to sell you, I have this wonderful insurance. Very few of us buy those. Success rate for these employees is less than 2%. In fact, it's less than 1% in several cases. So what do these companies want to do? They want to increase that success rate from 1% to 2%, 2% to 3%, 4%. What does that mean? It means that the agent who was making 100 calls a day and only one of them was getting converted will now make 50 calls a day and still get that 1% customer. So, and this is exactly what, for example, Google also does, right? It's trying to target you based on what it knows about, the queries you run. You write ISI Kolkata, it immediately knows that, you're probably an academic type of person. You send an email to your friend, I'm going to Kolkata tomorrow, it's going to send you, you see there on the right hand side, you're going to see ads related to travel, related to hotels, within the next 20 minutes or less. And why is that? That's because they are now creating that understanding of you, understanding what are your needs better, and serving you those ads. Of course, their revenue is also going to increase, but hopefully you're also not going to get tired of these ads and are going to click on some of these. So, one of the things that people are trying to do is to take this social media data and to say that, okay, there is this Ajay Sharma who is my customer. He is 25 years old. My traditional model says 25 years old, he's going to get married, he's going to have get into a job, he's going to buy a car in the next 3 years, he's going to buy a house in the next 5 years. So let me every 1 month, send him a home loan. This new strategy, they are saying that what are we going to do? We are going to look at you on social media. Ajay Sharma on social media. What are your interests? Did you say that I'm going to buy a house? Did you say to your friends that I'm looking for a house, so can you help me? Did you say I'm going to buy, which one do you suggest, Hyundai versus Maruti? Which car should I buy? That's what they're now looking for. They're saying that, can I, understand my customer Ajay Sharma better to serve him that more relevant ad, just the way Google has been doing so far. Everyone else wants to do that now, which is, your bank, which is your mobile service provider. As soon as I came to Kolkata, my phone, Airtel, they started giving me some offers for Kolkata, because now they know I'm here. Within a few seconds, they were able to determine I'm here and serve me ads which they thought were relevant. They are no longer going to tell me that, there is a sale in Vasant Kunj Mall in Delhi today, because they know I'm here. I'm not going to go there. But since they know I'm here, they're going to target me with ads more relevant to this case. Not only that, during, for example, the Anna Hazare movement, every day people were coming to Jantar Mantar, Ramlila Maidan. How was the police estimating how many people are going to? One, of course, traditional methods for police are, it says, okay, Anna Hazare, he's a Gandhian. He's not going to make trouble. So I'm not going to, I have 20,000 policemen in Delhi, maybe 50 are enough, because he never makes trouble. How do they estimate how many people are going to land up there? They say, okay, this guy, he's been popular somewhat. We are seeing some support here and there. And then they have their intelligence agencies and whoever else who estimate, saying that, okay, I think there are going to be 5,000 people there. How are they doing it today? They're looking at social media. They're saying, okay, how much buzz is there around Anna Hazare? How much buzz is there around Kejriwal? If he holds a rally today, they measure social media to see how much buzz is there, how much of that buzz is going to get converted. Now, this is not something new. Of course, elections, we've always had these poll surveys where they go out, they interview 2,000 people, 3,000 people per constituency, and then they come up with these new numbers. What is the new way? They do that, plus they do a social media survey. They try to see what are people from different locations talking about, who are they supporting, who has more buzz, who has lesser buzz, and in fact they changed their strategy. I mean, Obama in his last elections was run a lot on the social media. Why? Because 70% of the Americans are on social media. India, why did they not do that? 10% of people are on social media. So the government, or at least the political parties, did not care. But as soon as elections happened in Delhi this time, a lot of people in Delhi are on social media. That's why Kejriwal, BJP, Congress, they were also active on social media. And that's where, the accuracy has to be there. Now, if you are predicting that, the buzz around Kejriwal versus, that chief minister, previous chief minister, versus each of them, how much, then you have to be accurate. Somebody might make a spelling mistake, somebody might say, I love this guy, or anything. You have to be able to understand the different ways in which people express the sentiment. People might say, I love Kejriwal, but I don't like his education policy. I love this guy, but he's giving free water, so I don't think that's a good idea. So there are several, positives in that sentence, negatives are there. And when you analyze such text, and you're trying to say to Congress that, people are saying this about Kejriwal, you have to have some level of accuracy in what you say. And that's where the accuracy comes in. The second is, the Ajay Sharma use case. Ajay Sharma on social media, Ajay Sharma in my bank. Ajay Sharma is a very common name. There will be tens of Ajay Sharmas in Delhi, in HDFC Bank. Similarly, you go on Twitter, there will be hundreds of Ajay Sharmas. Who is the correct Ajay Sharma? So, of course, people can express intent in several ways. There is wishing for something, there is anticipating something, somebody is somewhere, so then they are talking about it. After the event, somebody says something, somebody is talking about their hobby. So all of these are very challenging things to understand. So when the bank is trying to understand what is your interest, it's still struggling, because the way you write things there is a challenge for them to decode and understand. And that's why you go to any NLP machine learning conference, you're going to see a lot of work around these sort of problems, around decoding what is being said, around parts of speech, around parsing, around classification, around clustering. And as you can see, in the past 3-4 years, the social media analysis, that's 40, 50, 60% of the papers in machine learning, KDD, TLDB, all of these top conferences, that's the kind of analysis they do. Why? Because one, this is interesting, the data is very freely available, the problems are plentiful there, and people are looking at very different aspects of several of them. Then of course there are very difficult things to understand for a machine. Things like spam. 50% of Twitter accounts are bots. What does that mean? 50% of these accounts are not of people. So if I am BJP and I want to show that my party is doing very well, I can just generate these spam bot accounts, and they will just keep sending some very good messages about their candidates or whoever else, right? So, and how does your system then separate out this from the rest of it? There have been several cases where people have actually spread rumors using social media. For example, the Meerut riots which took place, the police believes that WhatsApp was used a lot in that. The Northeast problem which happened last year also, a lot of people of Northeast started moving away from several states in India. It was a huge problem created out of rumors, pictures being posted on social media which were not true. And what does the government want to do? The government wants to get to these pictures before they create a problem. Today you drop any piece of information on social media, it doesn't remain static. It starts moving. Why does it start moving? Because it has a network structure associated with it. It's a graph, right? It's a graph of your friends and followers. It's a graph of retweets. It's a graph of sharing that content, resharing, and that same discussion also follows many contours. So somebody starts talking about corruption, that changes. Somebody says, oh, corruption in US is also there. Somebody says Kejriwal is out to root out corruption. Somebody says, these politicians are corrupt. So there are several aspects of that corruption that start getting discussed, and that starts spreading. So the information on the social media is not static. It's no longer that message which you post there. That's not it. It's also moving around, and that's what governments. That's what. If I'm a government, I don't want bad messages to spread. If I am, let's say, HDFC Bank, I want good things about me to spread. People saying good things about me. Everybody saying, oh, this bank is wonderful. Positive things about me moving around. If I'm a politician, I want people to be saying good things about me, and it to be pervasive across India. Let's say I'm Modi, for example, he's the PM candidate. He wants the whole of India to be talking about him, because then that means that in a positive way, because that means that he's sort of on the way to becoming that. Right? But all of this has this challenge that the spellings are not correct, the words are in error, the names cannot be resolved, and we saw these problems being talked about in the past 3 days, right? In the 3 days we looked at entity resolution, we looked at clustering, we looked at several of these problems, and it's only that we are not saying anything new here. All we are saying is these problems, when you look at it in the light of the scale of the data, the size of the data, and the speed at which that data is coming, it is a new problem by itself. If the government is trying to stop the spread of some hate messages, it doesn't want to come to know about that message 2 days after it was posted. It wants to come to know about it immediately. If I am a mobile service provider, somebody complains about me on social media, I don't want to come to know about it 2 days later when that piece of information has spread all over the social media. I want to come up to know of it immediately. But look at the scale here. This is 55 million Twitter messages every day. So it's high volume, high velocity, very difficult to understand. A lot of them have images. And so that's the challenge. That's the big data challenge that we're trying to face, with some of the known techniques being applied to this new multi-dimensional, high-dimensional, fast data that we're seeing. So some of the things that people have already started to do is to build these 360 profiles of people, as I said, which is to understand customers, which is to understand the electorate, which is to understand the demographics of the country. It's to understand what are the problems people in Kolkata are facing, what are people in ISI facing. A lot of city governments today are actually monitoring social media to do this. And in fact, even several of the police departments in India. So, for example, I live in Gurgaon, and the Gurgaon police has a Facebook page there where they respond as soon as you write something. They are very quick to respond, and they want to maintain that positive image, and they know that most people are afraid to go to the police and say things, but they are still willing to say the same things on social media. So they want to understand what are the problems people